we're going to calculate the slope, distance, and midpoint of these 2 points, J and K. So the first thing I like to do is label my points. So I'm going to label the first point x1, y1, and the second point x2, y2. It does not matter which point is the ones and which point is the twos. You'll get the same answer either way. So the slope formula, just to kind of remind you, is first of all, we use a lowercase m to denote slope. And then the formula is y2 minus y1 over x2 minus x1. So now all I'm going to do is plug in my x's and y's, and then we'll simplify what we get. So let's see, y2 is 3 minus y1, which is negative 5. So I do have a double negative here. It is going to turn into a positive 3 plus 5. And then in the denominator, x2 is negative 1, and I'm subtracting x1, which is 7. So in my numerator, I actually would have 3 plus 5, which is 8. And then in the denominator, I have negative 1 minus 7, which is negative 8. And when you divide those out, you end up getting negative 1. So that would be our slope. For distance, the formula is a little bit more complicated. Let's see, I'm going to write it up here at the top. So it's a big square root, and then inside you have x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of all of that. So I'm going to do the same exact thing. I'm going to plug everything in, and what I like to do is set up my entire formula except for the numbers, and that way when I plug in my numbers, I don't have to think about the formula and where everything goes. So I'm going to put in x2 minus x1, so that's negative 1 minus 7, and then in the second set of parentheses I'm putting in y2 minus y1, so that's 3 minus negative 5. And one thing you'll notice is that this part right here is the exact same thing as this part, and then this part here, the numerator, is the exact same thing as the second set of parentheses in the distance formula, and that will always happen. So if you've already done slope, you can kind of either check your work or maybe save yourself a little bit of thinking if you copy it down. So the next thing we have to do is simplify. So first thing I'm going to do is negative 1 minus 7 is negative 8. And then 3 minus negative 5 is positive 8 because I'm actually adding 3 plus 5. Negative 8 squared is 64. 8 squared is 64. So then when you add these two things together, we get the square root of 128. Now, unfortunately, we have to simplify this. We can't just leave it as 128. So we're going to do a factor tree. So 128, since I added two 64s to get to 128, I know that this is 2 times 64. 2 is a prime number, so I'm going to circle it, meaning that I can't go any farther. 64 is 8 times 8. If you recognize at this point that you have a pair of numbers, you can jump straight to the answer. If you don't see what I'm talking about, you can continue on with the factor tree and you'll get the exact same answer. It just takes a couple more steps. So now I'm going to break down each 8. So 4 times 2, and then this 4 is 2 times 2. And then same thing over here. So 8 is 4 times 2, and 4 is 2 times 2. So now I'm looking for pairs of numbers. So I see a pair of 2's here, a pair of 2's here, and a pair of 2's here. And then I have this 2 right here that does not have a pair. So what's going to happen is all of the pairs, one of each pair is going to come out to the front. So I have 3 2's that are coming out to the front, and they all get multiplied. And then this 2 that I had the arrow by over here is going to stay under the radical. So now the last thing left to do is multiply 2 times 2 times 2, which is 8. And then you have square root 2, so that's our final answer. Lastly, we're going to talk about midpoint. Midpoint, I think, in my opinion, is the easiest of all three. The midpoint formula is this. You have x1 plus x2 over 2 and y1 plus y2 over 2. So your answer for the midpoint formula is going to be a point. your answer for slope and distance are going to be numbers. So let's plug these in for the midpoint. And kind of like distance, I like to set up my answer, or not my answer, but my formula, and that way all I have to do is plug in my numbers. And actually we could even put in the plus signs. All right, so we're going to do x1 plus x2. So that's 7 plus negative 1. And then y1 plus y2 would be negative 5 plus 3. So now we're going to simplify. 6 plus, sorry, I'm saying the answer. 7 plus negative 1 is 6 over 2. And then negative 5 plus 3 is negative 2 over 2. And then our last step, 6 divided by 2 is 3, and negative 2 divided by 2 is negative 1. So that is our midpoint. Example 2 is just like example 1, except we have different points. So again, I'm going to label x1, y1, x2, y2. And now I'm going to plug it into all the formulas. So for slope, I have y2 minus y1 over x2 minus x1. And then when I simplify, 4 minus negative 6 is actually 4 plus 6, or 10. And 0 minus negative 4 is actually 0 plus 4, which is 4. And now I can simplify this fraction. Both of these numbers are divisible by 2. So if I divide both by 2, I end up with 5 over 2. And you want to leave your answer as a fraction because slope represents rise over run. So you want to have two numbers. It's more meaningful than having a decimal for slope. All right, distance. This is the hard one because you have to do so much simplifying. So again, I'm going to set up my formula. All right, so now I'm going to plug in my x2 minus x1. So I have 0 minus negative 4. And then y2 minus y1 would be 4 minus negative 6. 0 minus negative 4 is 4. And 4 minus negative 6 is 10. So what I end up with here is the square root of 16 plus 100, or the square root of 116. And now again, we need to check to see if we can break this down at all. So I notice that it's a even number, so I know I can divide by 2, and it turns out that it's 2 times 58. 58 is also an even number, and it is 2 times 29. 29 is actually a prime number. That means you can't break it down any farther. So we're done with our factor tree. So now what I'm going to do is take my pair of 2's here. That's going to go to the outside of the radical. And then left over will be this 29 because it didn't have a pair. So 2 square root 29 would be your final answer. And then last but not least, midpoint. So I'm going to set up my formula. And now I'm going to plug in x1 plus x2 would be negative 4 plus 0. And then y1 plus y2 would be negative 6 plus 4. So negative 4 plus 0 is negative 4 divided by 2. And negative 6 plus 4 is negative 2 over 2. And then finally, negative 4 divided by 2 is negative 2. And negative 2 divided by positive 2 is negative 1. So our midpoint would be negative 2, negative 1. Now before I move on, I just want to put a couple notes up here of things that you could possibly see. When you're doing slope, it is possible. There's two cases you need to be aware of. The first is if you have 0 divided by a number, and the second is if you have a number divided by 0. Because those two cases look very similar, but you get very different answers. If your 0 is in the numerator, your slope is 0. And what that means is that you have a horizontal line. It's like a flat surface. There's no slope to it. You're not walking uphill or downhill. If you have a 0 in the denominator, your slope is undefined. Or you might have also heard it called no slope. And what that means is that you have a vertical line. So it's not a hill because it's not something you could walk on. So those are two things that could possibly happen in your slope. In midpoint, I'm just going to put a little note here that I think it's better to use decimals than it is fractions. I said that it was better to use fractions for slope because you're doing rise over run. But as far as midpoint, if you're plotting a point, it would be easier if that point was in a decimal form as opposed to a fraction. A traveling circus from Los Angeles is going to their new destination in San Francisco. A coordinate grid is superimposed onto a map of California. Los Angeles is at the point 4, -5. So I'm going to use blue for Los Angeles, and I'm going to go right 4 and down 5. And I'm going to put a point here. So right here, this is the point 4, -5, and that represents Los Angeles. And San Francisco is at the point 6, 10. So right 6, up 10. So this is San Francisco. The map shows a rest stop halfway between the two cities. So part A asks us to find the coordinates of the rest stop. So the key word here is halfway. Halfway means we're talking about midpoint. So all this is asking me to do is find the midpoint of the points that represent Los Angeles and San Francisco. So I'm going to copy those points down. Los Angeles is 4, -5, and San Francisco is 6, 10. And now I can label these points. So I can say this is x1, y1, this is x2, y2, and I can plug it into my midpoint formula. And remember that when I do midpoint formula, my answer is going to be a point. So I like to set up my formula, and now I'm going to add my x's. So that would be 4 plus 6, and then I'm going to add my y's. That would be -5 plus 10. Let's see, 4 plus 6 is 10 over 2, and then -5 plus 10 would be 5 over 2. 10 divided by 2 is 5. 5 divided by 2 is not a whole number, it's actually 2.5, and I want to use 2.5, not leave it as a decimal, because if I do that, it's going to give me, it's not going to be as easy to plot. So one thing, since I have this graph over here, I want to plot this midpoint and see if it looks like it's in the middle. So I'm going to go right 5, and then I'm going to go up 2.5, and this is going to be my midpoint. I'm going to call it M. And I know it's not exactly perfect, but if you just look at it, it looks like it's in the middle of those 2 points. Part B asks us to find the approximate distance between San Francisco and Los Angeles. So what I'm going to do here is use the distance formula, and I'm going to first find the distance using the distance formula, and then I'm going to multiply my answer by, this scale here. The 1 unit equals 10.2 miles. Okay? So this one asks us to find the distance between San Francisco and Los Angeles. So I'm going to use my original 2 points. So the first thing I want to do is just copy those points back down. So my points were 4, -5, and 6, 10. And again, you can label them x1, y1, x2, y2. And I'm looking for the distance in between. So I'm going to use the distance formula. So I like to set it up, and then I just have to plug in numbers. So I'm going to do y2, which is 10, minus y1, which is -5, and then x2, which is 6, minus x1, which is 4. 10 minus -5 is positive 15. So I have 15 squared, and then 6 minus 4 is 2, so I'd have 2 squared. 15 squared is 225, and 2 squared is 4. So here's what I end up with, the square root of 229. Now normally I would say you need to take this and see if you can break it down into a factor tree and take anything out. But since we are going to take this answer and multiply it by this scale, we don't need to, because it's asking us for an approximate distance. The word approximate means you could use a decimal, first of all, But also, it's not meaningful for me to tell you, oh, it's the square root of 229 miles away. No one would ever give you a distance in a radical form. So it's okay for us to do decimals here. So what I'm going to do now is I'm going to take this square root of 229 and I'm going to multiply it by 10.2 because that's how many miles each one of these units represents. And when I multiply these out, and I'm rounding to 2 decimal places, it gives me 154.35. So that's how many miles apart those two cities are. Matt wants to buy a new video game at Best Buy. Here is a map of the 3 closest Best Buy locations to his house. Which location is the closest for Matt? So we have to do the distance formula 3 times because we have to find it once for each of the Best Buys, and then we'll compare those answers, and whichever one turns out to be the shortest distance, that would be the one closest to his house. So here we go. First thing I'm going to do before we even start is I want to label all 4 of these ordered pairs. That's going to allow us to put them into our formula more easily. So let's start with Matt's house. Matt's house is at the point 4, -4. Best Buy 1 is at the point 5, 7. Best Buy 2 is at the point -6, -4. And Best Buy 3 is at the point -4, +6. So I'm going to just go in order. I'm going to go Matt's house to Best Buy 1 first. So I'm just going to say BB1. That's going to be Best Buy 1. So we're going to do the distance formula here 3 times. Now the good news is that since we are looking for a distance, an approximate distance, it doesn't really matter if our answers are perfectly simplified. What matters most is that we can compare the distances easily. So at the end, we're just going to get a decimal because I think that's the easiest way to compare these distances. So I'm going to set up my formula. And I am actually going to write down my 2 points so that I don't get confused. So Matt's house is 4, -4, and Best Buy 1 is at 5, 7. Okay, so I'm going to make this x1, y1, and this x2, y2. So I'm going to do x2 minus x1, so 5 minus 4, and then y2 minus y1, so 7 minus -4. And if you wanted, you could go straight to your calculator at this point. I'm going to do the work by hand, but a calculator would be just fine. So 5 minus 4 is 1, and then 7 plus 4 is 11. So what I really have here is the square root of 1 plus 121, or the square root of 122. And then again, I told you I was going to use my calculator, and I get 11.05 approximately. So this is talking about, it doesn't give us a unit, but I'm assuming something like miles away from his house. All right, so now let's do Best Buy 2. So same thing. Now we need Matt's house, which is 4, -4, and Best Buy 2, which is -6, -4. So I'm going to set up my formula. All right, and then I'm going to label my points x1, y1, x2, y2. So I have -6 minus 4. And then my second set of parentheses would be -4 minus -4. All right, -6 minus 4 is -10. And -4 plus -4, sorry, -4 minus -4 is the same as -4 plus 4, which is 0. So I end up with the square root of 100, or 10. So this one I didn't even have to figure out the decimal because it came out to be a perfect square. All right, last but not least, Best Buy 3. So my points are 4, -4, and -4, 6. So I'll set up my formula. I'm going to label my points x1, y1, x2, y2. All right, so my first set of parentheses would be -4 minus 4. My second set of parentheses would be 6 minus -4. All right, so I get -4 minus 4 is -8 squared. 6 minus -4 turns into 6 plus 4, which is 10 squared. So right here I have 64 plus 100, or the square root of 164. And if you type that into your calculator and you figure out the decimal, it turns out to be 12.8. We'll say 12.81 since I rounded the other one to 2 decimal places. So 12.81 is the distance. So if you look at these three options, the shortest distance would be best by 2. So this one right here in the middle, because 10 is the smallest number, so it's the shortest distance. So our final answer to this problem, which location is the closest for Matt? We would say the closest location is best by 2.